Looks like we're ready. If you're just joining us, don't worry, you haven't missed much. We are just gonna start here with number one. Okay, so again, if you were here for Tuesday's lesson, this will be a much easier for you. If you're just joining for today, you didn't get a chance to see Tuesday's lesson, I would recommend that you, after this lesson, you go back and you watch the video for notes 48 because it kind of has the foundation for what we're gonna do more today, right? So today is just extension, it's adding more to it. All right, so like we talked about last time, we're going to think of this as a two-part problem because you have fractions in the numerator and you have fractions in the denominator, and the whole problem is one big fraction. So what we want to do is identify everything that's in our numerator first, right, which involves this entire highlighted blue part. Then I have this big fraction, right, this big division bar right here, right? So that kind of is the division between what is everything that's in my numerator and everything in my denominator. And then in my denominator, I kind of have this simple fraction down here. Okay, and so we talked about, okay, we're going to focus strictly on the numerator first. Whatever's highlighted in blue, we're going to kind of pull this off to the side and we're going to talk about it. And then what we have is 1 plus 3 over x plus 2 over x squared. Okay, and now the problem with this numerator is that now I have 3 different terms, but they do not have common denominators, right? Even this 1, right, because it's a whole number, I would need to make this a fraction somehow, and I can put a 1 underneath. Okay, but notice that what I would need here is that they need a common denominator. What do we think that common denominator would be? What do we need all those denominators to be so that then we can add the numerators of those fractions? Any ideas? Yeah, they all need to be x to the second power, right? Because that seems to be like the lowest common denominator there, x squared. So then in one case, in one of the fractions, the one that's furthest to the left, we're gonna have to multiply this by x squared over x squared. Okay, but the middle fraction, we're gonna have to multiply that only by x over x because that's multiplying x times x is gonna get us to x squared. Oh, sorry, I don't need x squared. Excuse me. Okay, so that's my numerator right there, okay? And then let me draw the big fraction bar in red. Okay, now in my denominator, when I bring this across, I have 1 plus 2 over x. Okay, in this case, it's a much simpler one, a much simpler case because what we have actually is just 1 over 1. And then if I wanted to then get these denominators to match, I would need to multiply the left fraction by x over x, okay? So we kind of have it set up now where if we multiply, now we're going to be able to combine everything. Okay, so let's go ahead and do that. We move over one more step. We have x squared times 1, that's just x squared. X squared times 1 is another x squared. Then we multiply x times 3, that's going to be positive 3x, all over x times x, which is x squared. And then we have plus 2, right? So that's just 2 over x squared. Okay, so now everything in that numerator, right, that big numerator, everything has a denominator of x squared. All right, now my denominator here, x times 1 is just x over x times 1 is x plus 2 over x. Okay, all right, so now let's go ahead and clean this up a bit. In the numerator, right, let me put my big fraction bar. In my numerator here, I can then add up x squared plus 3x plus 2 because they all have that common denominator of x squared. So I'm going to give it a denominator of x squared, and then I'm going to condense the numerator as one single expression. X squared plus 3x plus 2. Okay? Now the denominator, right, so that was, again, this is just my blue part. Let me highlight it so that we kind of keep track of where everything is. Right, this just got condensed to be written this way. And then in my denominator, right, this x plus 2 over x, right, we can write it as x plus 2 over x now. Okay? Okay, so then this led us to last time to then say, okay, now that I have a fraction over a fraction, it's much easier if we write it as division, right, with the actual division symbol. So we can write it as x squared plus 3x plus 2 over x divided by the other fraction of x plus 2 over x, right? Then in this case, what we want to do next is do the keep, change, flip. All right, now one other thing that I want to try to do before I even get to keep, change, flip is I want to see if I can factor this trinomial x squared plus 3x plus 2. The reason why is because what if there is a component there that is factorable that could then cancel potentially with the x plus 2? Who knows? Oh, sorry, did I miss something? This is x squared. Okay, so maybe there's something there that we can condense, right? Or I'm sorry, factor and then divide out. Okay, so let's just see. So this I'm going to turn into, man, I'm running out of space. Okay, I'm going to keep going this way to the left. So I'm going to write this as x plus, in this case, if I factor it, that's going to be x plus 1 times x plus 2, okay? Because 1 times 2 is 2, but 1 plus 2 is 3, so that factors. All over x squared. Okay. Oh, I ran out of space. Okay, hold on. Let me move this line down a little bit. Okay. Okay, so then that's my factored version. And I will then now, I still wrote it too. Let me push it over to the left a little bit. Okay, we had x plus 1 times x plus 2 all over x squared. Okay, so that's my keep, right? I kept it. That's my keep. However, I did factor it. Okay, then after that, we're going to do the change. Okay, we're going to change that from division to a product. And now we're going to flip this fraction here, right? So we're going to flip it and we're going to make it x over x plus 2. Okay, and I'm going to put it in parentheses. Okay. All right, so you can see now that there's a reason why factoring there was a good idea, because I can tell that x plus 2 over x plus 2, these two terms are going to cancel each other out, right? They divide out. And then not only that, but I have an x in the numerator with an x squared in my denominator. Okay, the x cancels, and then instead of x squared, now you're left with just x. Okay, so let's see what our final product ends up being. Okay, since I have x plus 1, if I multiply across in the numerator, there's nothing else left. It's just x plus 1. And then my denominator is just x. Okay, so then this leaves me with the final expression there of x plus 1 over x. Okay. So definitely more complex, right? A lot more moving pieces, more variables, a little bit of factoring this time, okay? But the idea, the concept is still the same. You still start attacking the problem by looking specifically only at the numerator, the big numerator, right? All of the fractions that are in the numerator, you try to combine those fractions, okay? You look for a common denominator amongst those, you combine them as much as you possibly can. Then in the denominator, the big denominator in yellow, you do the same thing. Like you look for the common denominator there so you can combine those fractions. And then once you do, then you convert that by utilizing the division symbol. That then makes it much more clear what you're supposed to do, because it then just becomes a multiplication problem. In some cases, like in this particular case where we had x squared plus 3x plus 2, it's not a bad idea to look to factor that, because you have other terms like x plus 2 which could potentially divide out, right? So then that's one of those cases where you have to think a little bit above and beyond and think, okay, besides just simplifying, can I factor, use what I know from before to even simplify further? Okay, any questions so far on this first problem? Okay, all right. Okay, let's move on then. Let's go on to the next one. All right, next one here, okay, same idea, right? Let's start by highlighting everything in my big numerator. Okay, everything in my big denominator, right? Separate colors. Hopefully you guys have some highlighters or some color pencils or something. Okay, and then I'm just gonna highlight over my big fraction bar to kind of distinguish between what is big numerator versus big denominator. Okay, so now let's kind of move and shuffle some of this off to the side. We have 1 over x squared minus 1 over y squared. Okay, in this case, I want those to be common denominators. Okay, what is it that I need to multiply to the fraction on the left that the fraction on the right has? Okay, what does it need? What does the one on the left need that the one on the right has already? Okay, all right, let me go back real quick, Kev, let me answer your question. Okay, so after I did a keep change flip, what I did was I did a shortcut here because I know that if I multiply, let me go back because I know that I did some canceling. Okay, I did some canceling there. All right, let me kind of show you what I did. Let me do the long, like the kind of long way. Okay, when I multiply these fractions across now, right? So I did my keep, I did my change, I did my flip. When I multiply across, here's what I would have gotten. Okay, I would have gotten x plus 1 times x plus 2 times x, right? All over. Then if I multiplied the denominators, I would have had x squared times x plus 2. Okay, so you see here, I have an x plus 2 with over an x plus 2. Those are the same factors, so I can divide them out. So they cancel, right? Now, what I did above is just I did a shortcut because I knew that when I multiply, I kind of just push everything together. So I knew that because I had an x plus 2 in the numerator and 1 in the denominator, they cancel out anyway, right? So you see, it works out the same. The other one that I canceled was also that I had in the numerator, I had x, in the denominator, I had x squared, right? So think about it, I have 1 in the numerator, but 2 in the denominator, right? So then one of those sets will cancel. This one cancels, right? So then how many x's are left over? It's just the one x on the bottom, okay? So the same thing that I did up there, but here I cancel out the x, and instead of having x to the second power now, it's just x, right? So I still have x there, but the square is gone. It's just x. Okay. So then as I move across, whatever's left over in the numerator, it's only x plus 1. So that's why I got x plus 1 here. And the only thing left in my denominator is this x here. Okay, so that's why I got x in the denominator. Okay. Does that answer your question a little bit? Does that help? Okay. All right. Cool. Sounds good. All right. So let's go back here. All right. So we were talking about what we needed to multiply to the left fraction so that it has what the right fraction has. In this case, because it has x squared and the other fraction has y squared, that means we're going to need to multiply by y squared on this side. Okay, to top and bottom. And then also on the right side, okay, because we have y squared, but the other fraction has x squared, now we need to multiply by x squared to both top and bottom. Okay, so that's where we are so far. All right, big fraction bar now. All right, now denominator, let's bring these over. I have x plus y, x over y plus y over x plus a 2, okay? All right, now that 2 doesn't have a denominator, so I'm going to give it a denominator of 1. All right, now this is where it gets tricky, right? Because first of all, I have 3 different values. I have x, y, and 1. Luckily, the good thing about 1 is that it can become anything, all right? So what is it that denominator, that common denominator could end up being in this case? Well, since one of them has y, the other one has x, and this last value is just 1, okay, I believe that each one of them is going to need an x and a y, x and y, x and y, okay? So here's what I need to multiply to the left fraction. This one has a y, but it does not have x, so I'm going to multiply by x to top and bottom. The next fraction, this fraction here, has an x, but it does not have a y in the denominator, so I'm going to multiply by y over y. And then the last one does not have either x or y. It does not have x or y, so I'm going to need to multiply both. So I'm going to have to multiply by xy, xy, okay? And then by doing so, each denominator will be xy, 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 okay? You guys follow on what I did there? Okay, all right. All right, let's keep going then. So then numerator, let's clean this up. All right, we want to multiply these out. So what we get is y squared over x squared, y squared, okay? And as tempted as you might be to simplify that, don't simplify it yet, okay? Because then it'll undo all the work that you just did, all right? So now the next one would be minus, now we have x squared over, again, this would be x squared, y squared. And again, don't cancel because it's gonna eliminate all the work you just did. Okay, all over, big fraction bar here. In my denominator, we get x times x. That's going to give us x squared over xy. Plus, now we have y squared over xy. Plus 2xy over xy. All right, so now let's go ahead and condense over here. Y squared minus x squared, that's going to be my numerator. Y squared minus x squared all over. Since they have that common denominator, I'm just going to bring over x squared, y squared. Okay, big fraction bar. Here they all have that common denominator of xy, so I'm going to have xy as the denominator, and then the numerator, I'm actually going to rearrange one of those terms because I see something. I'm looking ahead here and I can see that this is something that's going to be factorable. So I'm actually going to rearrange it as x squared plus 2xy plus y squared. Okay. All right, you guys with me so far? All right, so now let's go ahead and rewrite this as a division, right? So that we can then do keep, change, flip. Okay, so here's what I want to do. Let's go back down here. Okay, I'm going to write this as a y squared minus x squared divided by x squared y squared divided by x squared plus 2xy plus y squared over xy. All right, so now here we're ready to do a keep, change, flip. However, we have a lot of terms. Well, we have two terms that are factorable. Okay, if you take a look at this expression here, the y squared minus the x squared, what do we usually call something like that? Yeah, we have a couple of perfect squares and there's a difference of squares there. Okay, so we're gonna start by factoring that. All right, so I'm gonna factor this. I'm gonna factor that into x. I'm sorry, not x. I'm gonna factor that into y minus x and then y plus x. Okay, those would be my two factors all over the x squared and y squared. Okay. All right. Now I'm gonna do the keep, change, flip here. Okay, so just kind of follow with me here. This keeps, we're gonna change. So now we're gonna divide. Instead of division, we're gonna multiply. And I'm going to flip. All right, I'm gonna flip this last fraction. So then we're gonna send xy to the numerator. And then my denominator is going to be the x squared plus 2xy plus y squared. Okay, but before I write that all down, I want to factor it. Okay, I want to factor it. All right, so I know that this is one of these special cases. This is a perfect square trinomial, okay? So this right here, if you actually try to, let's say, you need to do your Xbox, that's fine, okay? I can see here that what I need to multiply in the front is x times x, so that's x times x. In order to get the y value, the y squared, that's y times y, okay? And in the middle, it has to add up to be 2xy, okay? So let me just real quickly show you where that comes from, right? We do some happy faces here. X times y is xy. X times y is another xy, right? So this is 1xy, that's 1xy. When you add them up, you get 2xy, which is what we were looking for, okay? So that is the correct factorization for that trinomial, all right? Now I'm gonna go ahead and erase some of this to kind of clear it up. Okay, so now, right, let's see. I can kind of push everything together, and then I can cancel, or I notice that I can just kind of start canceling from where I'm at. So I notice here that I have this expression, this x plus y, and then up here it's y plus x. Okay, now if I were to flip this one around, right, let's say I just kind of rearranged it and I called it x plus y, that's still the same thing, right? So y plus x is the same thing as x plus y. And so that is also the same thing as what I have down here, right? The x plus y. So let me erase this. I just wrote that to show you that they were the same. But you can see that y plus x and x plus y are the same, right? They are. So then those are going to divide out with each other. okay? Or I could have divided it out, you know, this other x plus y, okay? But it's only one, right? One on the numerator, one on the denominator, okay? All right, then after that, notice here that you have x, and then in the denominator, you have x squared, right? So then what you can do is, well, this x would cancel out with this x squared. Well, it takes the square away, and you're just left with x. The same thing happens with the y. Y cancels out with the y squared, and you're left with just y. Okay, so then what we can do is bring it over here. Let's look at what's left in the numerator. In the numerator, you only have y minus x. In the denominator, you have an x, you have a y, and you have x plus y. And then there is your simplified complex fraction. Okay. Any questions so far about what we've done? Okay. All right. I know it's a little challenging, so just try to stay with me. So if there's anything that didn't quite make sense, please let me know. But if we feel good so far, then that's a good sign. Okay. So yeah, I know it's quite a lot of work. Okay. All right. Well, it looks like we're okay so far, and so let's keep going. All right. I might cut this lesson short and just do 4 examples because it seems like this is taking quite a long time. All right, we'll see. Okay, so now let's take a look at something here. Again, big fraction bar. Okay. You have your numerator, highlight everything there. Your denominator, highlight everything there. Okay. Now this might look similar. There's just one subtle difference here. I want to kind of just recap real quick. When you get negative exponents, they belong strictly to the variable that is immediately the base of that exponent, okay? So for example, if I had x to the negative third power, what does that mean? That means I have to send x to the denominator. The power now shifts from being a negative to a positive. So what this meant was x to the negative third power is really 1 over x to the third power, okay? So negative power just means send it, flip it basically. Send it to the denominator. Now you get a positive exponent. If, for example, you had something else like 1 over x to the negative third power, right? Now imagine this, you have x with a negative power, but in the denominator, what does that mean? Well, now it's just the opposite. Now you send the x to the numerator, and you send the power up with it, but when you switch from being in the denominator to the numerator, it changes back from negative to positive. Okay, so that's just a couple of, that's just a review basically. This is something you should have seen in Algebra 1. Okay, so I just want to review that because we're going to use it in the next couple of examples. Okay, so I hope that is somewhat familiar. Yeah, negative powers. Okay, so let me just kind of erase some of this so there's some space. All right, so now here's what's happening. Okay, the reason why I'm accentuating this fraction bar is because what you are not going to do is you are not going to send this r down into the bottom. You're not going to send it to the denominator. Okay, here's what you're going to do. You're going to just keep that, right? That r is in that big upper part of your fraction, so it's going to stay there. However, it is going to be sent into the denominator of your numerator. Okay, so we flip it, right? You send r to the negative power into the denominator, but it's still up there. It's still part of that, okay? Plus 1. In your denominator, you have your r minus 1, right? Nothing changed about that, okay? So we've rewritten it, and now what you have is a series of, right, where you have one fraction plus a constant. In your denominator, you have, oops, wrong color. You just have r minus 1. Okay, so we're only going to deal with the blue numerator at this point, right? So if you had a 1 over r squared plus 1, right, what is it that we need to do to get those common denominators? Well, we can put a 1 underneath there, and it looks like the common denominator that they need would be r squared. So we can multiply top and bottom of that other fraction by r squared. Okay. So what we get now is 1 plus r squared over, right? They are both going to have that r squared denominator. Okay. That's my numerator. And then all over r minus 1. Okay, so now this becomes familiar. We just go ahead and rewrite this as 1 plus r squared over r squared divided by r minus 1. Right, since we're dividing by r minus 1 and this expression does not have a denominator, we can go ahead and put all of it underneath it. Or we can put a 1 underneath all of it. Okay, so that when we do the keep change flip, we have something to flip. Okay, so now we keep. So we have 1 plus r squared over r squared. Then we change that division to a multiplication. And then we flip this to 1 over r minus 1. And I'm going to put some parentheses around it. All right. Okay, so now if we move over, if we multiply across, right, this again, that's a binomial. We want to keep that together. So we have 1 plus r squared times 1. Multiplying by 1 won't change it, so we keep it as 1 plus r squared. All over. In my denominator now, that's r squared times r minus 1. Okay, and in this case, there's nothing to cancel. Remember that this 1 plus r squared is a factor, right? That those two terms are together, so you can't just cancel out r squared with r squared in that case, because it's 1 plus r squared, right? It's not 1 times r squared. So within those parentheses, those terms are stuck together. You can't just cancel r squared with r squared there. Any questions so far? Let's see. If you did put the r squared in the denominator, would it still be possible to solve it? Or if it's not, could you explain why not? Okay, here's the difference. Here's why you could not send it to the denominator. Okay, here's why. Just like I kept 1 plus r squared at the end in parentheses, I want you to think, what if I would have put parentheses here around this initially, right? What would happen? What would happen? Okay, so typically what you've seen before in like Algebra 1 is you may have seen things like this. Okay, and I need to talk about this to kind of explain why. You may have seen things like this. R, like let's say it was r to the negative 2 power and then s to the 5th power, right? But what's happening between this r and this s, right? There's no addition sign, it's a product. So when you have products, the terms can move around independently. But once you start adding things to them, right? You can't just abandon, you can't just abandon, let's say for example, your s, right? That part of the expression, because by adding them, now you kind of like stuck them together. So then like if you send the r squared into the denominator, then what happens to that s to the 5th? You just leave it in the numerator, right? And then if that's the case, then what do you do when you send it down to the denominator? Are you just going to multiply it? Or are you going to add it? What exactly do we do, right? So you see how there's no clarity in terms of like, what do we do if we do send it into the denominator? So you have to kind of ignore what's happening, ignore that you have a denominator in the first place. Ignore this. Hold on, how can I make it white on the inside? Right, ignore that this is even here. And just treat it, right? How would you rewrite this in the numerator only, right? And the best way to rewrite that is to just say, okay, well, I know that r to the negative 2 power makes that 1 over r squared, but then that is still being added to the 1, right? So I couldn't just send this piece, right, just like down to the denominator. Yeah, I don't know if that answered your question at all. Okay, it has to do with the fact that it's being added to 1. Okay, it's being added to 1. If there was no 1 there, then they could be treated differently. But because there is, and you're adding something with the 1, then that still has to be added to 1 even after you do the flip, right? So you still have to add that r to the -2 power to the 1. Now you just flip it and you make it 1 over r squared plus 1. Does that make sense? What happened to the r to the power of 2? Well, that's what we converted to. All right, let me erase some of this. Okay, so we took, Kev, to answer your question, this part, r to the -2, it became 1 over r squared. Okay, what you do with a negative power is that you send the base to a denominator, so you kind of flip it, and then you change the power from a negative to a positive. Okay, and then once I did that flip, the negative goes away. It becomes a positive power. Okay. All right. Anything else? Okay. Okay, let's move on to the next one. Okay, so here's an example, right? Here's an example, another one where we have a series of negative exponents. Okay, so again, I want to try to keep them in their natural positions, okay, by highlighting this big fraction bar. Okay, remember that here, everything in my numerator, that's essentially everything that's there. I want to keep it still above the red line. Everything that's down here stays below the red line. Okay, so I'm not trying to like move things up and across that red line, because eventually this is going to become like fractions over more fractions. So I don't want to start flipping things over. All right, so I just want to focus specifically on what is highlighted in blue. Okay, so ignoring that I even have a denominator, right? Ignore what's in yellow at the moment. If I were to rewrite this y to the -1 power, what I would need to do is I would need to put y in the denominator with a 1 in the numerator. Okay, now y to the -1 becomes y to the +1. Okay, by flipping it, right, now what you've done is you've been able to change that negative power to a positive power. Okay, plus, okay, now the same thing happens with x to the -1. Because that negative power needs to become a positive power, we're going to send that to the denominator with a positive power, and then we'll put a 1 in the numerator. Okay, do you guys follow what I did there? Okay, so you see I've still kept those two in my numerator, right? They're still part of the big numerator. Yeah, I didn't send anything into the denominator, like the yellow part, okay? Okay, now focusing strictly on what's in yellow, right? I'm ignoring that I even have a big numerator at this point. I'm only looking at this and how would I rewrite that? Okay, well, looking at y to the -2 power, okay, again, that's gonna tell me, all right, since I have a y to the -2, that's gonna mean I take 1 over y to the +2, but I have to send y to the denominator there, okay? Then I have minus, and then the same thing happens with x to the -2, okay? I would have to write it as 1 over x to the +2. Okay, you guys with me so far? Okay, all right, good, good. Okay, so now this brings us back to somewhat of a familiar place, right? We need to get these common denominators within those big fractions, right? The big numerator. So there I have two different variables. I have x and I have y, okay? You don't really need to keep the 1 as a power if you don't want it. I kind of find it a little bit distracting, so I'm gonna try to erase it. But if you like it, you can go ahead and keep it. okay? Because I know x to the first is the same thing as just x. So I'm going to go ahead and multiply this one by what I need. I need an x, so I'm going to multiply this by x over x. On this side, I need a y, so I'm going to multiply this side by y over y. Okay. I have the same issue in the big denominator, right? Look at this. I have y squared as denominator and I have x squared. So then they both need each other, right? So I need to multiply this left one by x squared. And I need to multiply this right one by y squared. Okay. Okay, so now let's see what's going to go on here. So now I have x times 1, which is just x, and then x times y is xy, plus I have y times xy. All over, actually, let me keep that in red. All over. In my denominator now, start making those products. X squared times 1 would be x squared times y squared, x squared y squared, minus y squared over x squared y squared. Okay, so there it is. There is our numerator and denominator. And now because they have those common denominators in the numerators, right, I can just condense that. That's going to be x plus y over xy. In the denominator, we have x squared minus y squared all over x squared y squared. Okay, so now let's go ahead and rewrite this as a kind of long division, right? So we have x plus y over xy divided by x squared minus y squared all over x squared y squared. Okay, you guys with me so far? Want to make sure I didn't lose anybody. Okay. All right, sounds good, sounds good. Okay. All right, let's keep going then. All right, so now we're gonna have to do a little keep, change, flip. We're gonna keep, we're gonna change, we're gonna flip, and then we're also gonna factor because I noticed that this right here, what do we call that? Difference of squares, yes sir. Okay, so we're gonna have to factor that, but we'll do that on the flip, okay? So then we'll keep here as x plus y over xy. We change this to multiply. When we flip, we're gonna send x squared, y squared up. And then I have this x squared minus y squared, all right? So then what I'm gonna do here is I'm gonna change this to x minus y times x plus y, right? That's the factored version of a difference of squares. So I'm gonna put this in parentheses as well, okay? And here, I'm gonna just, this time I'm just gonna condense everything and then cancel, okay? So I have x plus y times x squared, y squared, all over x, y, x minus y, x plus y. Oh, that's a, what? That's a y, not a 2, my fault. Okay, so we have some factors here that can be divided out. So we have x plus y over x plus y. That definitely cancels out for us, okay? If I have 2 x's on top and 1 on bottom, one of them cancels, okay? So then this x is gone, and then that's no longer x squared, it's just x. Also, this y cancels out with the y squared, so y is gone, and then that just becomes y, right? So the square cancels, all right? So in my numerator, let's see what's left here. We have xy, so x times y, all over. In my denominator, the only factor left is x minus y. Okay. All right. Any questions on example number 4? DOS, DOS, funny. Okay. All right, I think I'm just gonna show you one more just because there's like some subtleties in what do you call it? In some of these negative exponents. Okay, so I'm going to show you. Here's what I'm going to do, actually. I'm going to show you how to set these up. Um, I think the most important part is just rewriting it correctly, because the rest is like what we've seen before. All right, so if we can kind of get through the correct rewriting, then the rest, you know what to do. So on these last two examples, we're just going to practice how to rewrite them with the correct, right after we flip the negative exponent. All right. Okay, so let's start here. First one. I don't want to make this too long for you guys. Okay, so for that numerator, right? Highlight everything there in blue, denominator, everything here in yellow. Okay. All right. So if I move across, right, I would have 9 minus, and then since that's a negative power, okay, I'm going to have to write that as 1 over k to the second power. And then I have my big denominator. I'm sorry, my big fraction bar. Now, in the denominator, this is where it gets tricky. This is where mistakes happen. Typically, what students make the mistake of doing is that when they see the negative exponent, they want to try to apply the negative exponent to the whole thing. Okay, but that's incorrect, because if they meant for you to apply the negative exponent to the whole thing, you would see it written this way in parentheses, which means you would send the 3k down to the denominator. Okay, but since those parentheses are not there, that means that this -1 exponent only belongs to the base immediately in front of it. Okay, so it really only belongs to k. 3 has its own separate power. 3 has an invisible power right now of a 1. So you are not going to send 3 into the denominator. You are only going to send the k into the denominator. Does that make sense? So here's what I mean, okay? If 3 has a +1 power, 3 is going to stay in the numerator. But you're going to have to send k, this part here. That part goes into the denominator there. Okay, k to the first, or just k. All right. If, let me just show you, if it was like this instead, then you could correctly say 1 over 3k. Okay, because there the -1 power applies to the whole thing. Okay, but because we don't have that, we only have 3 times k to the -1, then the correct way to rewrite that is over here, 3 over k. Okay, is that clear? Yes. Okay, and then clear. Good. Sounds good. Okay, and so then what happens next is we can say, all right, so then the next one is just minus. It's just k to the -2, so then we can write it as 1 over k squared. Okay, so from here, I believe that you would be able to complete the problem, right? Because you know that, okay, now in my numerator, I know that I need a common denominator between those two, so I can put a 1 underneath, and I multiply by k squared on the left. Down here on the bottom, this denominator, big denominator, right? They don't have the same denominator yet, so you would have to multiply this one by k over k, and then you could keep going, right? But I think that's the big key there, is that when you have a product 3 times k to the -1, it's important to understand which one stays and which one goes. Okay, so I'm going to leave it there, okay, because I think you guys know how to do the rest. So the important part is just the converting part, rewriting. Okay, so it's definitely not done, but I trust that you guys would be able to finish it up on your own. Okay, all right, now let's take a look at the next one. This one, same idea, right? There's a subtlety here, especially in that numerator. Do you see it? Okay, what is not there? There's no parentheses, right? So that means that m is not supposed to be sent into the denominator. That means the only variable that goes is going to be the n, right? So let me highlight everything in my numerator here. Highlight my denominator. Well, let me highlight my fraction bar first. Denominator. All right, so now let's go ahead and do this. I have 1 minus, now m is not in the parentheses. That means m has its own power. It has a power of 1. So m is going to stay, but then n is going to be sent to the denominator there. So you're going to send n down to the bottom. Okay, fraction bar, big fraction bar. Okay. Okay, here we have m to the negative 1. All right, that's easy. We just go 1 over m. Then we have n to the negative 1. We're going to do minus 1 over n. And there you go. Right, that's it. So that's our setup. And then again, I think from there you would be pretty able to take care of this, right? You see that in your numerators here, you would need a common denominator, right? So go ahead and with this big 1 that you have, just put a 1 underneath. And you can see there that you would have to multiply this by an n over n in order to get them to match. In the denominator here, in order to get those to match, the one on the left, you would need to multiply by n. The one on the right, you would need to multiply by m. And then I think from there, you would be able to continue.